This video is going to cover modified Poisson regression, and this is a way to get relative risks from odds ratios when the rare disease assumption isn't met. And just to kind of start, I'm just going to go over what relative risks are, what the odds ratios are, and what the rare disease assumption is. So this table is illustrating data from a study where the outcome is dichotomous, you're diseased or you aren't, and exposure is also dichotomous, you're exposed or you aren't. And A here is the number that are exposed and diseased, B, the number that are exposed and not diseased, C, not exposed and diseased, and D, not exposed, not diseased. A plus B here is all who are exposed, C plus D are all who are not exposed. So the odds of being disease positive among the exposure positive group is just the number that are exposure positive and disease positive divided by the number that are exposure positive and disease negative, so A over B. And the odds ratio is the ratio of the odds of being disease positive in the exposure positive group, A over B, over the odds of being disease positive among the exposure negative group, C over D. And yeah, you sometimes might see it cross product style where it's like A times D over C times B. But yeah, it's a ratio of the odds, an odds ratio. Risk, on the other hand, is pretty much just a proportion where with the odds it was A over B and C over D. For risk, the risk of being disease positive among exposure positive is the number that are exposure positive and disease positive over all of those who are exposed, so A over A plus B. And similarly to the odds ratio, the risk ratio is the ratio of the risk in the exposed over the risk in the not exposed. So A over A plus B divided by C over C plus D. A lot of people prefer relative risks over odds ratios. A lot of people find it difficult to interpret odds ratios. So we look for situations where we think that odds ratios are kind of an approximation of the relative risk. And the situation where that is kind of true is when the disease is really, really rare. And I'm just going to go over why that is. So like A and C is the diseased column, and B and D is the non-diseased column. So when the disease is really rare, A and C are very small in relation to B and D. So what that kind of lets us do is say that A over A plus B is kind of equivalent to A over B, because as far as this denominator goes, B is accounting for all of it pretty much. Like we can say B is like 1,000 and A is like 8, where like adding A to this denominator isn't going to change this fraction that much. And same with C, where C over D isn't that different from, C over D isn't that different from C over C plus D because C is so small in comparison. So what that lets us do is say that A over B divided by C over D is a kind of equivalent to this relative risk formula. And in that way, we can use the odds ratio to estimate the relative risk. So just kind of putting that together, for binary outcomes, we use logistic regression. And logistic regression produces odds ratios. So when the disease is really rare, we can use logistic regression to we can use the odds ratios from logistic regression to estimate relative risks. An alternative, that's the conclusion. An alternative is that another thing that happens when the disease is rare is that the binomial distribution approximates Poisson distribution. So that means this data is suitable for the Poisson regression. And in that way, we can calculate, we can get a little bit more direct estimation of relative risk or rate ratio from that. However, there's a lot of situations when the disease is common and binary. And in that case, both of those two things break down because the odds ratio from logistic regression doesn't approximate relative risks. And also, our binomial data isn't no longer approximating Poisson distribution, so our standard errors are going to be very off. But with modified Poisson regression, we basically recognize that that's the only thing going on here, and if we're able to quantify the amount that it's off by, we can get robust estimates of the standard error. And that's basically all modified Poisson is. This is kind of an anticlimactic video, just because all I'm going to tell you now is just that the steps of getting relative risk from common binary diseases is fitting it as a regular Poisson and then requesting robust standard errors. And this is an alternative to log binomial. Log binomial is another distribution that lets you, I guess, get relative risk from common binary diseases. But it has some problems that I'm not going to go into in this video, and a lot of people prefer modified Poisson.